Good morning, good afternoon, or good evening, everyone, based on where you're in the world. And thank you so much for joining us. If you've got expensive, powerful GPUs or compute resources, and they are sitting around waiting for data to load, that's a huge waste, right? The root cause is often that your shared file system is slow, unreliable, or just too much work to manage yourself. It introduces lots of unnecessary friction. So today, we're going to tackle that friction head on in this webinar titled Network File Storage for High Performance AI/ML Workloads. I am Ananta Ramachandran, product marketer for DigitalOcean, focusing mostly on the infrastructure as a service products. I'll be co-presenting this webinar with my colleague, Chaitanya Reddy, who's the product manager for our new network file storage solution. So here's what we'll cover today in this session. First, we're going to be giving you practical, no fluff insights about how to avoid common network file storage related pitfalls. Right? We're going to be talking about things like best practices to mitigate I/O contention, manage data gravity, and stop paying for the hidden tax of having your expensive compute resources sitting idle for data to load. Second, we'll also provide an overview, a technical look at our new product, DigitalOcean's network file storage service. This is key. We'll show you exactly how this fully managed solution is purpose-built to help you deliver high throughput, low latency performance that complex, say, AI/ML workloads and collaborative teams need to truly scale. And finally, we'll also show you a demo, right? And finally, we'll leave you with the concrete next steps to easily evaluate and integrate network file storage into your existing architecture. Our goal for this session is simple, right? For you to leave this session with a clear path to a more performant and cost-effective network file storage. So let's dive in. For those of us who are attending this session and are new to DigitalOcean, right, and are exploring DigitalOcean, I'm going to spend the next 1 or 2 minutes giving you a brief overview about DigitalOcean. I'll start with what we are all about, right? So at DigitalOcean, we are on a mission. We are about making cloud and AI simple so that digital native enterprises like you can spend more time building software that changes the world. And if you look at DigitalOcean's global footprint, right, we are powering customers worldwide. Right? We provide robust infrastructure, reliable network connectivity, and storage to businesses around the globe. Right? And DigitalOcean data centers are certified to meet the top security, compliance, and sustainability standards to protect your data and ensure trust. Now, why DigitalOcean? Right? Like. Before that, it's important to realize what's happening in the market, right? Most hyperscaler clouds aren't a good fit for many growing digital native enterprises because many hyperscalers can be overly complex, cost prohibitive, and lock you in contracts and offer only limited support, right? That can be extremely constraining for a growing enterprise like yours, right? Specifically, it creates a lot of unmet needs. For example, you may be operating lean teams, right? You may be a growing digital native enterprise, which offers tons of products or services that are powered by cloud and AI, right? You may be one such digital native enterprise, right? And you don't have armies of DevOps or cloud ops or FinOps specialists. You need a cloud that's simple to manage across its entire lifecycle, right? And that's where we come in, right? DigitalOcean delivers a simple, full-featured cloud that's easy to scale as your needs grow, and all backed by enterprise-grade SLAs to support your mission-critical products. And we're also a trusted partner, not a walled garden, right? Because most our customers enjoy transparent, predictable costs, 24/7 support. So you'll get it when you need it the most, and the freedom of an open ecosystem that grows with you. So in short, DigitalOcean offers simple, scalable, and approachable cloud and AI services. And that's the difference that many customers enjoy today, right? And if you look at what we offer, DigitalOcean offers comprehensive cloud and AI services, right? All the way from, like, we primarily, at the core, we primarily provide infrastructure as a service, offering virtual machines that we call as Droplets, a variety of storage solutions. By the way, in this webinar, right, we offer spaces object storage. We also offer volume block storage, and we also offer network file storage. In this session, we'll dive a bit more deeper into network file storage. We also organize tons of webinars. In fact, a webinar every Wednesday a week to talk more about a lot of products and services that we offer and how they can help you mitigate a lot of your current challenges and help you grow as well. But in this webinar, we'll focus more on the network file storage product that's available within the storage portfolio. So as I said, we offer infrastructure as a service. We also offer platform as a service, right? For example, we offer a variety of managed databases, Kubernetes, app platform, and also the Gradient AI platform, the recently released Gradient AI platform for your AI ML needs as well. So on top of that, we also offer tons of software as a service. For example, we have a very vibrant marketplace where a lot of our partners provide add-on solutions that extend or complement DigitalOcean products and services as well. And we also offer web hosting solutions and tons of Gradient AI applications and agents as well. So we offer a variety of products and services to suit the unique needs of many growing digital native enterprises. But as I said, this session is mostly about network file storage, right? So before sharing a bit more about the new product, I wanted to share some common challenges and ways to avoid those challenges and get more value from your network file storage, right? So based on tons of discussions and research with existing customers and seeing what's happening in the market, I wanted to share some of the common pitfalls associated with network file storage, right? The first and foremost critical hurdle is the I/O performance contention, right? This is the difference between a successful distributed job and one that constantly stalls, right? When multiple GPU droplets or expensive computer resources are, let's say, GPUs are trying to read a massive training set simultaneously from a generic storage layer, you often hit a wall of inconsistent latency, right? The high performance file system is supposed to be an accelerant, right? But if the backend I/O can't sustain the needed low latency and the high throughput, right, your entire cluster would come to a grinding halt, right? And that will slow things down. This is a common failure point in many self-managed storage solutions. Next, hand in hand with that is a fundamental issue of lack of performant concurrent access as well, right? For applications like, let's say, a distributed AI model training or video rendering, right? You need absolute guarantees that multiple nodes can access the exact same file at the exact same time without any data integrity issues or even corruption and things like that, right? Achieving this reliably and at scale is a significant engineering challenge, especially when trying to maintain strict POSIX compliance for mandatory file locking, a requirement that many legacy applications and say specialized tools cannot compromise on, right? So beyond the technical performance, there are also challenges related to operational overhead, right? Like we have several engineers and developers, cloud ops folks attending this webinar here, and we have others in your company as well, right? So look, ask any of us or any engineers in your company, right, who has deployed, let's say, a production grade Ceph for a Gluster FS cluster, right? It's complex, right? And a staff intensive undertaking, right? The expertise required to ensure high availability, redundancy, seamless patching, and non-disruptive capacity scaling often pulls lots of critical resources away from core product development into these kind of activities, right? That's a lot of overhead, right? And finally, the scaling and availability risk is also a key challenge. Scaling up capacity is one thing, but then the performance in lockstep while maintaining guaranteed uptime is the true measure of a reliable shared file system, right? So poorly implemented solutions often introduce downtime or data access inconsistencies, right? Precisely at the moment then you need to scale the most, right? Like challenges happen at really awkward moments, right? These operational headaches are precisely the reason many digital native enterprises, growing businesses that rely on cloud and AI, right? Look for managed solutions, especially for, let's say, network file storage. So these are some of the common challenges and pitfalls. And let's look at some of the ways to reduce these friction and reduce the cost related to network file storage as well, right? There are several ways, but what I want to focus on is a couple of them. For example, the first one that I would suggest us to consider is, again, the goal is not just to reduce costs, right? Like it's not just cheap storage, right? It's about optimizing the total cost of ownership for data intensive workloads, right? And that's what I want to share here, right? So the most common cost trap that we see is over provisioning and capacity waste, right? That's one of the top cost drivers. So the first thing that I would say is it's important for us to right size, right? That's paramount, right? Many solutions force on, let's say, a high minimum commitment, right? Like let's say when you go to a hyperscaler or any other cloud provider in the market, right? They may expect you to commit to a higher storage purchase, for example, 1 terabytes, sometimes even 5 terabytes before even you start generating production data, right? This is pure wasted capital, right? Do not spend more for over provisioning, right? You need a solution that allows you very granular allocation based scaling, right? Starting with tiny increments, right? You only pay for the storage you actually consume and need, right? And secondly, the nature of network file storage as a shared storage is an inherent cost reducer, right? So instead of, let's say, let me give you an example, right? Instead of, let's say, copying a 500 GB training data set to 5 different GPU virtual machines, right? 5 different GPUs, right? Consuming, let's say, 2.5 terabytes of expensive storage on those GPUs, right? You can centralize the single source of truth on a network file storage. This eliminates data duplication and associated wasted capacity and helps you reduce cost and improve total cost of ownership, right? And then the next thing that I would suggest is, it's a bit little obvious, but highly technical. The cost factor is compute idle time as well, right? For example, let's say if you have a expensive GPU or a variety of droplets for, let's say, analytical workloads and things like that, right? That are still idle, while waiting for massive chunk of data to load over a slow IO path. You're burning significant amount of money, right? So network file storage, NFS, with its high throughput and low latency engineering, ensures your most expensive resources like a GPU or a premium virtual machine are utilized at maximum capacity, let's say for like a model training or rendering, driving down the effective cost per unit of work completed, right? In essence, you're just accelerating your time to market and reducing the hourly burn rate of your compute, right? Finally, the shift from, let's say, a self-managed to a fully managed file storage is a direct OpEx win, right? Like operational expenditure win, right? The most sophisticated network file storage systems require dedicated staff hours. We just spoke about it a minute ago, right? You need your high valued resources for, let's say, activities like patching, monitoring, securing, or even scaling, right? Like calculate the cost of engaging those high value staff versus simple, predictable fee for a managed service that is straightforward. It's a straightforward cost benefit analysis that always favors and tips towards a managed solution, right? And then as a pro tip, like I would end with the final tip, which is to think that and recognize that not all data is hot, right? Not all data is frequently accessed, right? For example, for long-time archives or historical logs or model checkpoints, right? The most effective cost strategy involves some kind of a data hierarchy or data tiering, right? So you could use high-performance network file storage for your active hot data, right? But ensure that your design or your architecture allows you for a seamless transition or an archiving mechanism to a highly cost-effective solution like cold storage tiers. So as I said before, DigitalOcean also offers a variety of storage solutions. One of them is called as Spaces Object Storage, which is an S3 compatible storage. And we recently released the capability for customers to enjoy cold storage at a much lower price, right? So yeah, so consider various data tiering as a strategy to reduce your overall storage cost and also improve and get more value from your network file storage, right? So those are some of the common challenges and some of the ways to reduce friction and reduce costs related to a network file storage, right? And we've covered some good challenges and good tips, generic tips that a lot of customers use, right? All the way moving from the painful reality of IO contention, data gravity attacks, right? So those are things that you can avoid using these tips. Now, DigitalOcean has a solution that makes it super easy for you to avoid those challenges and organically adopt the steps, right? And that is called DigitalOcean's network file storage, something that we recently released, and it is generally available today. To share more about that specific product, I now invite Chaitanya to walk us through that, please. Chaitanya, take it away.
Thank you so much, Ananta. Hello everyone, and I hope that this tips and tricks that Ananta has shared is really useful to you. I'm Chaitanya Reddy, and I am the product manager for network file storage at DigitalOcean. NFS is our new solution for shared access file storage, and we have just launched it recently this week. So I'm really excited to tell you more about our product, its features, and how things are working. Uh, So NFS as a product is basically the third pillar or the third offering from our DigitalOcean storage portfolio. So right now we have volumes, which is like a block storage, and spaces, which is like an object storage or an S3 compatible storage. So NFS is our third solution, for which is for a shared storage solution. And NFS that we have designed is optimized for GPUs and GPU workloads. It's optimized for AIML workloads, training and inference workloads, high performance compute workloads, which would allow you to have parallel reads and writes across multiple compute nodes. So the idea is to create and manage file shares on the go from our DigitalOcean console and attach them to multiple droplets at once. So what happens is you can access that particular shared file storage using multiple droplets. So it gives you really high performance and less latency within your VPC. So it's like an intra VPC setup that you have, and it also supports GPU droplets and Kubernetes. So you can have attach your DOKS clusters or nodes on to your NFS droplets, wherein you can create persistent volumes, have create using standard storage classes, and mount your PVCs on your DOKS clusters. So it supports both your GPU nodes and your Kubernetes nodes, and it's available currently in Atlanta data center. We had the GA launch in just this week, this Monday. So we're really excited to add more data centers. We have New York coming up next week. We have Atlanta, we have Toronto and Amsterdam and San Francisco data centers coming up soon with NFS. Uh, when we talk about what exactly are we trying to solve with NFS, so the idea is to have shared data sets without having multiple copies, without having duplicates. So initially, what happened is like we we usually can have like one droplet attached to one particular storage, but with NFS you can have large data sets accessible through multiple droplets. And the idea is to have one data set and multiple nodes or multiple workers working on that particular storage. Now this allows you multiple advantages and multiple solves multiple challenges. Like you can go faster with your model training and media pipelines. You can have parallel IO reads and writes across different nodes, and that drastically reduces the storage runtime. uh, and for NFS, we have this DO simple formula where we wanted to give simple operation procedures for our users, where you can create your NFS share, provision the storage you want, and attach the NFS to your droplets within minutes. And we have a demo coming up in the next few slides where I'll double click on how to create an NFS share and attach to your droplets. Uh, and uh, and moving on to pricing, we kind of wanted to have a very predictable and a simple pricing formula, which is capacity based and can scale as you scale up with your needs. And we have a separate. I would like to double click on pricing, which is a very interesting area for our customers as well. So we have a slide for pricing in the coming deck. And another thing is we even support snapshots in our NFS. So snapshots, as you must know, like it is basically to preserve your data, create an in-state copy, and it is ideal for rollbacks and protect your data before you retrain or transform your data, so that you can come back to that particular point of data where which you stored. And in NFS, snapshots are basically read-only checkpoints. So we have a different pricing for that as well, which I'll cover. And when you consider what are the use cases where NFS can be used. So firstly, as I've told you, we have AIML use cases wherein a single NFS share can be made to manage and pre-process large data sets, and that can be trained across multiple clusters of GPU droplets. We have media and content use cases wherein, like, you can take an example, say a video agency is using a shared storage of NFS, and it allows multiple designers or multiple developers to work on the same project or the same files without having to move data across different workloads, different droplets. Similarly, we have analytics and data analytics use cases wherein a company is storing ETL staging data, and there are multiple compute droplets wherein they are using these droplets. They are trying to transform the data, aggregate the data, and do a particular operations. But that all can be done using a single NFS share, and that's where NFS comes into picture. And there are scientific and research use cases wherein, say, a genomics research team, mounts an NFS share and across multiple nodes to process your sequence data. So those are some of the use cases that we can consider for NFS. So next is the pricing, which is a very interesting slide, I would say. So in NFS, we have a very simple and transparent pricing model, and that is being continued for NFS as well, wherein you're only paying for what you provision. So the NFS pricing starts at 30 cents per gig per month, and it's just a flat pricing, and based on the number of GPUs and the number of GPU nodes and clusters, we can offer you a discount somewhere, but the basic price starts at 30 cents per gig. And we have snapshots, which is like a full storage an NFS snapshot, and that is billed separately at 6 cents per gig per month. So you have an NFS share, you can take a snapshot and you can roll back to that state whenever you want, and which is much cheaper, much cheaper than the standard NFS pricing. And that will help you in having backups and help you restore your data whenever you want. And saying that, we have no extra charges for IOPS or throughputs. We have, since it's optimized for AIML and GPU work cases, the throughputs are really high. We support up to 1 Gbps per GPU droplet, and it scales, and it's not like a standard throughput, right? It scales as you grow. As you grow the share size, as you attach more GPU droplets, you get more network traffic, and you can scale your performances, your read-write IOPS, and your throughputs accordingly. And you can attach multiple droplets or Kubernetes clusters without any additional cost. So with the current pricing model, say a 1 TB of NFS share would fetch you like what, $300 per month, and a 500 gigs NFS share would fetch you would cost you $150 per month. So that's the pricing model of NFS, which is very simple, and we wanted to keep it very predictable for our users. Now I'll quickly go through a quick demo, if you allow, and in terms of demo, I would like to tell you a use case wherein where say I'm a developer, or I'm an engineering manager of a tech company, and and we run an e-commerce company, and for that e-commerce company there are multiple challenges, there are multiple things that are going on at one point, wherein the marketing and we have, say, so that e-commerce website is basically running on a DigitalOcean web droplets, and there's a load balancer behind which we have like 2 to 3 droplets on which the e-commerce website is hosted. Now there are multiple things that are going on at once. We have the marketing teams that are updating the product catalogs. We have the in design teams that are updating the banners or campaign data frequently because it's a sale going on. And then we have and the problem with this scenario is, based on the traffic, or based on where the users are routed, uh, they are using cron jobs to actually sync the data asynchronously, wherein if you're uploading one data in one droplet, half of the users can see it and half of the users don't see it. There's a delay between them. And that's where NFS comes into picture. So I'll just quickly share my screen, and I hope you can just, yeah, I hope my screen is visible. And and this is basically the DigitalOcean DigitalOcean Cloud Console. And as I've told you, we had volumes, block storage, and spaces object storage. And this is network file storage is our latest offering. So I'll just tell you how to create an NFS share. You can go ahead, create an NFS share. You can select the data center. And as I've told you, NYC2 is a fast follow. We are getting it pretty soon. So I can create a NFS share in Atlanta, and I can select the VPC that I want. I can select the storage. It starts at 50 gigs per month, and you can increment in 10 gigs. So I'll just create an NFS share with 100 gigs of storage. I'll say uh, NFS demo share. I can give a name, and okay, yeah, my bad. I can't use space in the naming of the NFS share. So I just go and create this particular NFS share, and that's it. 100 gigs NFS share is being made. Now, once that NFS share is created, you can go ahead and create and use the mounting instructions to actually, install your NFS common library on your droplet, and on your droplet you can mount the NFS share using the mounting instructions. You just have to mount using NFS commands, and you should make a directory in your home, and you should be able to directly see the NFS share on your droplet. Now, uh, I'll just uh, I'll just use I'll just share my screen once again and show you how we can actually use that NFS on a droplet. So now I've created an NFS share before, which was like 150 140 gigs, and in that I had a VPC attached to it, and I've attached two droplets to that NFS share. So if you see, this was my VPC, and I have two active droplets attached to this NFS share, which is all inside a VPC. So I have two droplets. One is an Intel Atlanta droplet, and one is an AMD Atlanta droplet. Now, if I go here, you can see that I have been logged into these two droplets. This is the AMD droplet, and this is the Atlanta droplet. Now, if I go and see what all do I have, you can see that I have there's 140 gigs of storage and 16 gigs is used. Now I have four files in it. Now, based on the e-commerce example that we just took, if say I create a directory saying, hey, one is for the marketing team, wherein I can just create a storage which just has a folder product catalog. And now I can also create another directory which just has the banners or the campaign data. So this is how I can see that there are two new folders created, catalogs and banners. Now if I go to my other share, I can just do an ls, and I can see these two folders are available here. So that's how the shared storage thing is working in NFS. Now what I can do is I can just go back, and I have this 140 gigs of storage. I'll go ahead. I can have the option to change the VPC, or attach it to a different VPC. But one thing I can do is I can go ahead and resize my storage as my needs grow, right? As my traffic grows or my website grows, and as I support more and more things, I can go ahead and resize the share, and I should be able to see a share from 140 gigs resized to 150 gigs. So that's how you see 150 gigs of NFS share. And now if I go here and check if that's done, you can see, hey, this is a 150 gig storage now, and 16 gigs is used in it. So that's how simple it is to actually go and provision an NFS share, resize your NFS share, and use it for multiple droplets needs. So the thing is, like, once this is done, all your uploads for your e-commerce website are now instantly shared across server. The marketing, design, and engineering teams are in sync, and there are no more broken image links. So that's the main advantage of how NFS would work. Over to you, Ananta. And we have a Q&A session after this, so if you have any questions, do let me know. But that's in how NFS would work.
Thank you, Chaitanya. Very nice demo. I love the example of an e-commerce company that is having multiple collaborative teams that are running multiple types of applications, and they need a shared home drive, right?
Correct. Yeah.
Right, and data integrity, latency and throughput are critical things for them. Love that example. That's a very common example as well. I also listen to lots of calls between our sellers and customers, right? Like this one resonated really well with me, because like one such conversation that I heard was one of our customers were having multiple web server clusters, right? And they were looking for a common file storage to share all the common static images and things like that, right? And so what an e-commerce company would experience and get benefit from NFS is something that any startup creating their static website could get as well. So highly relevant example. Really appreciate it. Yeah.
Okay.
So again, so folks on the audience here, right? Like you've heard some really good information about common challenges, tips to avoid that. Then you had an overview about DigitalOcean's new product called Network File Storage, and also saw a demo here. Please feel free to ask all your questions on the chat window here. Chaitanya and I would love to just answer all of them, and also like connect with you and follow up and help you learn more and get started on network file storage as well. So with that, I'm just going to bring back my original slide and then move it to the Q&A session, right? So Chaitanya, we'll have some questions coming on the screen here. But I'll just read them out to you and let's just tackle them together, right? Like one of the questions that I think Nikos has is, by the way, like Kevin, Michael, and Nikos, so nice for you to join here, and others who are on the call, so nice for you to join here. Please do ask your questions on the chat window here. But one of the questions is, Chaitanya, when will network file storage be available in Amsterdam?
That's a great question. So we have Amsterdam in our roadmap, and it should be available somewhere in December Q4 of 2025. So that's the plan. So we have everything in place, and things are moving really fast. We have a lot of GPU demand as well from Amsterdam. I'm aware of. So I know how critical NFS is for them. So we're really working forward for it, and we should be available in Amsterdam by this quarter end, I would say.
Lovely. That's good news because like usually Jan is a lot of planning happenings, right? Like a lot of our customers do
Correct.
infrastructure planning during Jan, and it'll be timely. So it looks like we're already available in Atlanta, New York
Yeah,
City, New
NYC is
York's data
just
center is a
NYC,
couple
New
of days
York is
away.
just yeah.
Amsterdam is coming to, and we're going to fast follow in a couple of more data centers, right? Like I
Yeah, so we're going to fast follow in Toronto and San Francisco data centers, and we and based on the GPU demands, we'll decide on the next uh, couple of NFS data centers. But the thing is, it's not just about GPUs. We're also so this particular NFS that we have, it's for GPU oriented or it's for high performance. But people who want shared storage for CPU droplets or less intensive, less performance intensive workloads, we're also planning to have a lower performance tier wherein it's more ideal for app platforms or CPU droplets. So that's again one of the things that we are going to launch pretty soon, and a lot of
yeah
things are going on in the back end, I
yeah
would say.
yeah. So it looks like lots of interest. Look, people are looking for availability in more data centers. So thank you for providing a roadmap on how it will be available. We'll fast follow and make it available in more data centers. There are questions on. So there are more questions. There are questions on like request to make it available in London as well pretty soon and things like that. So Chaitanya, hopefully we'll fast follow into more data centers. So Michael, thank you so much for your question. We'll consider that request and prioritize in our planning as well. There's another question about whether it will be available in Kubernetes as rewrite menu for PVC. I mean, this is a great question. I know we have a good answer. So Chaitanya, take it away.
Will it be available in Kubernetes and read-write menu for PVC? Yeah, it is available for in Kubernetes as a read-write for PVC. So it's basically a manually you have to create YAML files and create your persistent volumes and create your persistent volume claims and then provision them as an NFS storage class to your Kubernetes clusters. But we actually have a private preview customer who is using it as a read-write menu for PVC. So that's a use case that a customer is already working on. So we do support that right now.
Oh, lovely,
Ananda.
lovely. Can you share a bit more about that use case, Chaitanya, of how a customer would use Kubernetes, NFS together? Can you share a bit more about that?
Yeah. So as I would say, like there is one customer who's an AI customer, and he's using it in our private preview for inference use case. So basically, what are they trying to do is they're running Hugging Face model for their GPU cluster nodes. So for people who need a little bit of who for a little bit more context on how Hugging Face models are used, it's basically an open source library of pre-trained models where users can download the models and fine tune them based on the use case. And the use case differ from different like image recognition, speech recognition, text generation, and all those inference use cases. Now, this NFS customer is using this pre-trained model for classification, and they have integrated our NFS solution in their inference setup. and they're using Kubernetes nodes, wherein they have like multiple nodes and clusters of Kubernetes of a GPU workload, a GPU droplets, and they're running NFS, and they're getting really good results as well, like what based on what we've heard in private preview in terms of the read write throughput and read write IOPS.
Mhm. Thank you. Great use case. Very common use case, right? Um, thank you. There's another question, Chaitanya. Like they want to know a bit more about the specifics on performance, right? Like,
Yeah.
can we share anything on stats or what customers are enjoying today and where we want to get? So share a bit more details about the performance for NFS.
Yeah, so regarding performance, we are pretty early in our basic testing scenarios, but we found a really good performances. Like each of our droplet actually supports up to 10 Gbps read write throughput of per droplet. But right now, what we are supporting is at least 1 Gbps per droplet per GPU droplet, and that would scale based on the number of droplets as you increase, and based on the storage size. Like for 500 gigs and 1 TB of storage size, you would have a different you would have more enhanced performance profiles for each of the NFS shares that we'll have.
Thank you. Thank you. So Chaitanya, as questions come along, right, there are also some common popular questions like um, DigitalOcean offers S3 compatible spaces, right? And then we also offer volume block storage, and then there's network file storage, right? Like how should customers think on which is the right one to choose for that particular application or a use case?
Got it. Yeah. So that's a really interesting question. Like a lot of people do get confused about like which kind of storage should be used for which. So when we say that NFS sits right between volumes and spaces, it's basically NFS is kind of the missing middle layer in our storage portfolio at DigitalOcean. So we initially had volumes, which was our block storage. And the thing with block storage is it's very ideal for attaching it to a single droplet. It is very ideal as a local storage. Like whenever you spin up a droplet, all the root or OS files, they kind of spin up from your bootable block storage or volume storage. They're also ideal for databases or single instance workloads. And whereas Spaces or the S3 object storage is ideal for large files or static assets, media, and backup files. Now, NFS is where we have a shared POSIX compliant shared file storage, which can be accessed via multiple droplets. And it is ideal for AI, training, inference, and analytics use cases that we saw. So it's a very interesting use case where NFS fits in. And it was a very big ask from a lot of customers historically. We had like a lot of customers wanting this NFS from a really long time. So glad we are finally, here with this solution.
Thank you. Thank you. I do want to add on to that. So yeah, like network file storage is a clear use case for, let's say, AI ML workloads, right? All the way for like distributed model training or collaborative data science teams or even AI data pipeline processing, right? It's a clear complementary fit for such AI ML applications or workloads. But there are also some additional use cases that I've heard. Like, for example, I initially shared about web server clusters, right? When you have multiple web servers, NFS lets all your servers share the same files and assets, like such as a website content, images, or user uploads and things like that. So that's something that we shared earlier. I want to draw attention to another key use case that I've heard some customers consider NFS for, which is like for data pipelines and analytics as well, right? For example, let's say it's common for many enterprises to run analytics jobs or batch processing across several machines, right? It could be even CPU droplets. Like NFS allows each server to read from and write to the same shared data set, right? This is ideal for big data analytics too, right? Like not just the AI ML machine workloads, but big data analytics too, or any pipeline that requires data from multiple compute nodes to be centrally stored and accessed as well. So just wanted to share that data pipelines and analytics is also key use cases that many customers are considering this for, right? So Chaitanya, there's another thing that I wanted to ask. Um, I'm just looking through the questions here.
Yeah.
I'm not able to understand this question clearly. Perhaps it will help resonate better with you. Like, there's a question on, I think it's a question about when RWX will be generally available.
Um, so our WX is basically read write execute. So it's uh, It is available, generally available. Like if you are making an NFS share, you are able to read, write, and perform any operations on your NFS share. So if that's the question, I mean, it's right now available in our NFS, so it should be good
Yeah,
to go.
yeah.
Yeah,
Thank you for asking the question. Hopefully, we've answered that. If not, if you can just clarify what that question, we'll be able to provide a much more pertinent answer if you understand it better. Um,
yeah,
so, like, so Chaitanya, can you share a bit more about like there are many network file storage solutions available in the market, right? Like,
yeah.
like what's the unique value that our customers enjoy that's not available elsewhere? But before we answer that question, I think we have a clarification. They just wanted to know rewrite many, whether that is
Uh,
generally supported within NFS.
okay, read write many. I'll just have to confirm once. I'm not sure, but like what I believe it should be available. But again, I can get back to you, Jinrich. As like I'll just confirm once with my for K8 rewrite for K8. Yeah, it is available. Yeah, rewrite many for K8 is available. Yeah, thanks for clarifying. But yeah, it's available right now in our GA launch.
Yeah, thank you. So, like,
Yeah.
I want to get back to the question. Like, there are many network file storage solutions available in the market. What are top reasons why customers choose DigitalOcean's network file storage, and what's the unique value that they enjoy?
Yeah. So, in terms of unique value, one thing is like we start really low, like in terms of even pricing for pricing performance, we are pretty much good on the pricing side. We are very economical in terms of how we are charging for our snapshots. We try to create consistency across our different snapshots offerings. Like for volume storage, we have snapshots. For droplets, we have snapshots, and all are charged at 6 cents. So that really makes easy for the customers. And in terms of when you actually want to provision your storage, a couple of other hyperscalers kind of start really high. Like if you want an NFS share, you have to go for 1 TB and 1 TB plus. But here at NFS, we are starting as low as 50 gigs of storage, and as much as you want, it's available in tens of increases. Like you can go into any multiple of tens and increase your storage and resize your storage as you want. So you'll be only charged for what you are actually provisioned, and based on the needs, you can just have a limited amount of storage for your business needs as needed.
Thank you. That's great, Chaitanya, especially for growing digital native enterprises, right?
Correct.
Like a lot of hyperscalers, they expect you to commit to a large amount of data set commitment, right? That's just like it's like jumping into an ocean, right? Like if you want to just dip your toes in water and incrementally grow the usage, right? Like that's where the simplicity and approachability of DigitalOcean shines in our pricing and packaging model, right? You can start with small increments with extremely competitive price, extremely tailor-made for digital native enterprises that want to grow their business and not without breaking their bank, right? So thank you for sharing that. I know we are about to close here. Thank you all for your questions and your engagement. Again, what we want to share is that we've covered a lot of ground here, right? Like we started with what are some of the common challenges related to file storage and what are some of the ways to avoid the friction and reduce storage costs. Um, we also provided an overview of network file storage, a recently released product from DigitalOcean. You saw a demo, you saw the pricing plan and use cases and things like that. So as a next step, right, hopefully you got enough information here. But as a next step, we suggest these two paths, right? So if you're evaluating a new cloud platform for your growing business, right, this solution can be that simple, scalable, affordable platform for your business, right? So you can scan the QR code that you see on the left-hand side of your screen to just get a $200 credit to just try DigitalOcean, right? So it's a scan, get the $200 credit, and play around with DigitalOcean. We offer tons of resources, all the way from virtual machines to storages to networking to AI to managed databases. There are tons of things that are available. So get started through this $200 credit and see how DigitalOcean's simplicity, scalability, and affordable pricing can help you grow your business, right? However, if you're an existing customer who's attending this webinar or watching this session, right, and you want to add network file storage as part of your DigitalOcean's account, right, like you can log into DigitalOcean console today, right? You saw the screens that Chaitanya showed in the demo. Those are available already because this product is generally available, right? So you can log into DigitalOcean console. On the left side, left nav, you would see the network file storage. You can click on it and you can play around by creating NFS and then sharing with your teams and see how simple and how effective that network file storage is, right? However, if you have some complexity, let's say you have petabytes of data, or you have some complex setup, you need some more guidance, you need some more custom advice, right, or solutions, right? Like experts are available to help you, right? That's another DigitalOcean difference, right? So we have a form that you can fill up where you can share details about the complexity or your unique requirements. Experts like Chaitanya will just get back to you and we'll have a conversation and provide the right guidance to help you get started and break down that complexity, simplify things for you, and help you get started as well, right? Again, thank you all for the engagement. I do see a final comment from Michael on the chat window here. Thank you, Michael, for sharing some additional use cases as well, right? Like especially dealing with unstructured data sets like images. There's also a question on whether structured data will likely be sourced from data lakes and warehouse and things like that. So thank you for that comment and for the question. Chaitanya, do you want to answer that quickly before we wrap the session? Chaitanya, you're on mute, I think.
Sorry. So in terms of you're absolutely spot on, Michael, regarding the NFS use cases, wherein we say that structured data is most likely coming from data lakes or warehouses. But even for NFS, we have like data like LLM and RAG pipelines or audio and video machine learning pipelines or tasks, or basically inference sharing services. All this coming from NFS. So even for unstructured, even for structured data, there are a lot of NFS use cases, I would say. And yeah.
Thank you. Thank you. Again, folks, thank you all for your interest and attending interest in DigitalOcean network file storage and attending these. Please use these suggested next steps that you see on the screen here. Again, at DigitalOcean, we are on a mission to create cloud and AI services that help you create software that makes a change in this world, right? Hopefully, the network file storage can help you accomplish that using the simple, scalable, and approachable solution that we have. Thank you so much for your time and interest, and have a good day. Bye.
Thank you, everyone.